The CJ3000 was sold online as China's next big strike at Boeing. Some creators called it a Boeing killer. Others claimed it would power future Chinese widebodies and push Western engines aside. But there's one thing almost none of those videos ever mentioned. The CJ3000 wasn't a secret engine program or a new step in China's race with Boeing. It was a student project from Beihang University, a design made for a competition, not a factory flaw. So how did a university assignment end up being talked about as a threat to Boeing and even Airbus? Why did so many people believe China had a new engine ready to shake up the aviation world? To understand how the CJ3000 story got this far, we need to go back to where it actually started, before the story took off and before anyone claimed it could trouble Boeing. When you strip away the claims and the loud titles online, the CJ3000 turns out to be something far more ordinary. It was a detailed academic design made by students at Beihang University for an AIAA engine competition. A triple-spool, mixed-flow concept for a future supersonic transport, not a wide-body airliner. No factory, no test stand, no government backing. Just a team of students running simulations in gas turb and meeting the rules of the contest. The design lived quietly online for years. The report sat on AIA's website and on Mirrored Tech Archives, where it was mostly used as a teaching reference. In academic circles, it was treated exactly as intended, an example of how a modern turbofan could be designed for a high-speed civil aircraft, nothing more. But that quiet life didn't last. The moment the diagrams spread into forums and social feeds, people saw more than a class project. It looked advanced, it looked official, and for creators chasing attention during the rise of the C919 and China's real engine programs, it looked like a perfect story to amplify. The shift from a quiet student design to a supposed threat to Boeing didn't happen overnight. It began the moment parts of the CJ3000 report started circulating outside academic circles. The diagrams were clean, professional, and filled with data that looked like something pulled from an industry portfolio. Most people who stumbled across them had no idea they came from an AIAA student competition entry. As the file spread, small fragments of context fell away. The Beihang University labels were often cropped out. The page headers showing the competition name were ignored, and pretty soon the tables were being reposted as if they were taken from a real AECC development program. The timing didn't help. China's C919 had just entered commercial service, and the CJ1000A engine was beginning to appear in public test footage. People were already primed to believe China had more engines in the pipeline. In forums and comment threads, the speculation started small. Could this be linked to China's next widebody? Is this the engine for the C929? But speculation spreads fast when it fits a broader narrative. Many viewers were already expecting China to push ahead in aviation technology, and the CJ3000 diagrams seemed to confirm it, even though they never said anything of the sort. Then the videos arrived. Several creators began presenting the CJ3000 as a confirmed Chinese engine. Some claimed it was a future rival to Western power plants. Others blended it into discussions about the C929 and C939 widebodies, even though neither COMIC nor AECC had ever mentioned the design in any official document. Many of these videos referenced each other rather than primary sources, and the myth snowballed. By the time those uploads gained traction, the story had already drifted far from reality. Viewers came away believing the CJ3000 was an active program, a new contender in China's aviation race. The fact that it was nothing more than a classroom design never even entered the conversation. One reason the CJ3000 myth spread so easily is that the original design looked convincing in every way that mattered. The Beihang team didn't submit a loose sketch or surface-level outline. They delivered a full concept, complete with cycle analysis, component breakdowns, material choices, thrust tables, and a complete mission profile for a supersonic transport. To anyone outside the engineering world, it looked indistinguishable from a real proposal. The layout alone was enough to confuse people. Triple spool architecture, a mixed flow path, a bypass ratio close to 3, an overall pressure ratio near 4 to 5. These are features that appear in serious high-performance engines, and the CJ3000 data matched what viewers expected from something with real industrial backing. Even the fan and compressor descriptions, polyimide composite blades, titanium leading edges, and stage compressors sounded like something you'd see in an AECC briefing. Then came the performance numbers. Thrust ratings around 70,000 pounds at takeoff. Fuel burn figures that beat the baseline design by about 10%. A cruise profile at Mach 1.6 around 50,000 feet. For a student project, These numbers landed surprisingly well, and because they were generated in gas-turbine, the tables looked polished and official. Nothing in the report shouted student work, so when creators copied these charts into videos, viewers assumed they came from a state research lab. The materials section added even more weight. The CJ3000 proposal used ceramic matrix composites in the turbine stages, titanium metal matrix composites in the compressors, and other advanced alloys. These are the same classes of materials found in Western engines like the GE9X and Rolls-Royce Trent families. Seeing them listed gave the impression that the CJ3000 was already aligned with cutting-edge civil engine design. All of this made the design appear far more advanced than it really was. In reality, these choices were part of the competition rules, encouraging students to explore future-ready solutions. But once the diagrams left the context of the AIAA report, they began to look like internal documents from an actual Chinese engine program. And that illusion set the stage for everything that followed. The strange part is how easy it would have been to spot the truth. None of the usual signs of a real engine program were there. No test cell photos. No manufacturing partners. No filings with aviation regulators. No public statements from AECC, COMAC, or any state-backed engine institute. Not even a hint in China's own 5U aerospace plans. Yet this lack of evidence didn't slow anything down. The claims grew anyway. Some videos insisted the CJ3000 was already chosen for China's future wide-bodies. Others said it would challenge engines used on Boeing's long-haul fleet. It didn't matter that the design was made for a supersonic transport, a completely different class of aircraft. The stories were too loud, too confident, and too easy to repeat. This is where the myth reached its peak. A student design with no funding and no industrial backing was suddenly being talked about as China's next move in the global engine race. And for many viewers, that misunderstanding became the truth. Once the CJ3000 hype took hold, comparisons to Boeing appeared everywhere. Viewers thought China had a new engine ready to shake up the market. Some creators even claimed it would go after engines that power Boeing's wide-body fleet. But none of that lined up with reality. Boeing never treated the CJ3000 as a threat, and neither did Airbus. Industry analysts never listed it in any chart, report, or forecast. There was no program, no testing milestones, no supply chain, and no certification path. In fact, aviation experts barely mentioned it at all, because there was nothing to mention. The real engines shaping China's rise were already public. The CJ1000A for the C919, and larger projects like the CJ2000 for future long-range jets. Those programs had test rigs, partners, and state funding. The CJ3000 had none of that. It lived only in a student report and in the imaginations of people who wanted a dramatic headline. By the time this became clear, the myth had already traveled too far. Anyone searching for China's next move found a story that looked believable on the surface, but had no foundation behind it. This is where the whole story breaks wide open. Because once you compare the claims with the facts, the gap is impossible to ignore. The CJ3000 wasn't hidden. It wasn't secret. It wasn't leaked from a state lab. It was sitting in plain sight on an AIAA website as a student entry. The entire report openly states it is a preliminary design study made for a competition. Not a funded engine. Not an active project. Not a prototype in waiting. But none of that matched the version spreading online. Creators talked about test stands. They talk about future wide-bodies. They talked about Boeing watching China close the gap. None of those details came from AECC or COMAC. They came from each other. That's the real twist. The CJ3000 never changed. The story around it did. A classroom design for a supersonic concept got pulled into global rivalry talk. A few bold claims turned into a narrative. And before long, audiences believed China had built an engine that didn't actually exist. This was never a Boeing story. It was a story about how fast the internet contains solid engineering homework into the next big threat. Now that the dust has settled, the truth is hard to miss. The CJ3000 didn't fail, stall, or get cancelled. It simply never existed as a real program. It did exactly what it was meant to do. Help students learn how to design a high-speed turbofan and present it in a formal competition. And once you understand that, the rest becomes easy to see. There was no supply chain, no certification timeline, no industrial backing, no role in China's future wide-bodies, and no reason for Boeing or Airbus to care. China's real engine push is happening in plain sight, with the CJ1000A, the CJ2000, and military engines like the WS-20. These are the programs that matter, because they have funding, hardware, and a clear path forward. The CJ3000 simply got pulled into that world by accident, then amplified by creators who wanted a dramatic headline. What the CJ3000 really shows is how fast a technical document can turn into a global talking point once the context disappears. So in the end, this engine was never what people thought it was. It wasn't a hidden breakthrough or new chapter in China's push against Boeing. It was a smart student design that got pulled into a conversation it was never meant to be part of. But here's the part most people miss. While the CJ3000 was being turned into a legend, China's real engines kept moving forward. The CJ1000A is already flying on test beds. Larger engines meant for long-range jets are in active development, and those programs have the potential to shift the balance in ways the CJ3000 never could. If a student project could spark this much noise, imagine what will happen when one of China's real next-gen engines hits a full flight test. That's the story worth watching. If you want the facts without the noise, make sure you're here for the next one.